Hi boys and girls, here's Unit 6, Lesson 13, Reintroducing Inequalities. So for each inequality, find two values for x that make it true and two values that make the inequality false. So what I'm going to do is I'm going to make a table here, just on a rough sketch, and we're going to have our true, and we're going to have our false. Now the numbers that I'm putting on here are just examples. There's really many different numbers that you could come up with for these, okay? So these are just my examples. So here, to make this true, we have x plus 3 is greater than 70. So I need any value that is greater than 70. So I could pick, well, I could pick 70 for x. 70 plus 3 is 73, and that is greater than 70, so that would work. Okay. I could, I don't know, do 80. 80 plus 3 is 83, and that is greater than 70. Okay, to make it false, I need anything that's going to add up to 3 and be less than 70. So let's do, I could do 50. 50 plus 3 is 53. That is less than 70. That would not be greater. And I could do, well, let's just do 40. And that would give me the same as it being false. 40 plus 3 is 43, and that is less than 70, not greater. Okay, 2, or B, I have x plus 3 is less than 70, so now I'm going the other direction. So a number plus 3 that's less than 70, well, I could do 33. 33 plus 3 is 36, and that is less than 70. Let's do 12. 12 plus 3 is 15, and that is less than 70. Okay, what can I do to make it false? Well, I'm going to have to make it more than 70 to make this false. So I can do 67. 67 plus 3 is 70. That is not less than 70. It's equal to. And I could do 72. 72 plus 3 is 75, and that is not less than 70 either. Okay, this next one, we have negative 5 times x is less than 2. So I'm picking a number times negative 5 to be less than 2. So I'm going to pick any positive number here because negative times a positive stays negative. So let's do positive 2. Negative 5 times 2 is negative 10, and that is less than 2. Let's do 5. Negative 5 times 5 is negative 25, and that is less than 2. Now we need to make it false. In order to make this false, I'm going to have to multiply by a negative. So let's do negative 1. Negative 5 times negative 1 is a positive 5, and that is definitely not less than 2. Let's do negative 3. Negative 5 times negative 3 is a positive 15, and that is not less than 2. All right, here we have 5 times x is less than 2. So here I'm going to pick negative numbers to make this true. So I could do, or I could even do 0. 5 times 0 is 0, and that is less than 2. Or let's do negative 4. 5 times negative 4 is negative 20, and that is less than 2. Now I'm trying to think of ones that would make it false. So if I multiply by any positive number, that is going to make this false. So let's do 5 times 6 is 30, that is not less than 2. 5 times 1 is 5, and that is not less than 2. That's kind of how we do that one. The next one, here's an inequality of negative 3x is greater than 18. List some values for x that would make this inequality true. So I need to be greater than 18, so I'm going to have to multiply by a negative number. So I could do negative 8. Negative 3 times negative 8 is 24, and that's greater than 18. I could do negative 10. Negative 3 times negative 10 is 30, and that's greater than 18. Negative 7. Negative 7 times negative 3 is 21, and that is greater than 18. So there's some possible values there. Again, I could have anything here that would make that true. So my numbers are not the set numbers. B, how are the solutions to inequality negative 3 times x is greater than or equal to 18 different from the solutions to negative 3 times x is greater than 18? Explain the reasoning. So these inequalities here could have mostly the same solutions, except one would have a or equal to. That number would be, if I took -3 times -6, that would give me 18, which would work here. So for this inequality here, x could be -6. But for this inequality, x would have to be anything that is less than -7. So this one, instead of equal to, could be anything less than -6. So this inequality includes -6, and this one does not. Okay, 3, match each sentence with the inequality that could represent the situation. So Han got $2 from Claire, but still has less than $20. So Han has some amount of money, he got $2 more, and he has less than $20. So x plus 2 is less than 20. That matches with 3. May spent $2 and has less than $20. So May has X amount of money, she spent $2, she has less than 20. That would match with number 1. If Tyler had twice the amount of money he has, he would have less than $20. So twice amount of whatever he has less than 20. So that would be 2. If Priya had half the money she has, she would have less than 20. Well, that would match with 4. Okay, number 4. Here are the prices for cheese pizza at a certain pizzeria. You had a coupon that made the price of a large pizza $13. For what % off was the coupon? So the regular price for a large pizza is $16.25. So what I'm going to do is I'm going to take $16.25 minus $13. And the difference is $3.25. So what I'm going to do with that now is I'm going to divide that difference by the original amount. So I'm going to take my $3.25 and divide it by $16.25, which would give me 0.2. And that would be 20%. So you got 20% off. B, your friend purchased a medium pizza for $10.31 with a 30% off coupon. What is the price of the medium pizza without the coupon? So we don't know the price of the original pizza, so that's our unknown. And we're going to multiply it by not 30%, but we paid 70% to equal that total of $10.31. So I'm going to, in fact, divide both sides by 0.7. So $10.31 divided by our 70% is, well, it's approximately $14.73. So the price of a medium pizza is around $14.73. Okay, C, your friend has a 15% off coupon and $10. What is the largest pizza that your friend can afford, and how much money will be left over after the purchase? Well, they only have $10. So I don't think they're going to be able to buy that large, and I don't think they're going to be able to buy the medium, but they might be able to buy that small. So let's find that 15% of $11.60. So $11.60 times our 15% gets us $1.74. Oops, 74. So I'm going to subtract the $11.60 minus $1.74, which gives me $9.86. So yep, that's right under $10, so they can purchase it. And he wants to know, so they can buy a small pizza And how much money will be left over? So we're going to take our $10 minus the $9.86. So they're going to have 14 cents left over. Okay, 5. Select all the stories that can be represented by the diagram. So Andre studies 7 hours this week for end of the year exams. He spends 1 hour on English and an equal number of hours each on math, science, and history. Okay, so 7 hours, so this could represent the total hours. This could represent the 1 hour is on English, and that could represent math, science, and history. So it looks like A could be represented with this diagram. B, Len spends $3 on 7 markers and a $1 pen. Well, let's see, 7 markers. I would have to see 7 sections of markers. Yeah, B does not work there. All right, C, Diego spends $1 on 7 stickers and 3 marbles. So this would have to be $1 and have my 7 markers and 3 marbles there, so that's not going to work. Noah shares 7 grapes with 3 friends. He eats 1 and gives each friend the same number of grapes. Okay, so I have 7 total grapes. He shares with 3 friends. He eats 1 and gives each the same number of grapes. So D, yep, that would work for that diagram. E, Elena spends $7 on 3 notebooks and a $1 pen. So this could be my $7 with my 3 price of notebooks, and this would be my $1 pen. So yep, E would work. All right, please let me know if you have any questions.